So then after scientists Hallwrach and Lenard performed some experiments related to the effect of light on the metallic surfaces. So how they observed this effect? Which type of experiments performed by these scientists? So first they took negatively charged zinc plate and that was connected with electroscope. So when negatively charged zinc plate was taken, connected with electroscope, and then after it was illuminated by ultraviolet light, then they observed this thing, the negative charge on the zinc plate decreases. Then they repeated this experiment. Then after the experiment was repeated by neutral zinc plate. And when neutral zinc plate was illuminated by ultraviolet light, they observed this thing, the zinc plate becomes positively charged. Again, the experiment was repeated with the positively charged zinc plate. And when positively charged zinc plate was illuminated by ultraviolet light, they observed this thing, it becomes more positively charged, or we can say more positive. So all these experiments leads to only one thing. When the ultraviolet light incident on the zinc plate, negatively charged particles are removed from it, and these negatively charged particles are nothing but electrons. So resultantly, they proved this thing, when ultraviolet light incident on the zinc plate, electrons are emitted from the zinc plate. And then after they repeated these type of experiments for different metals, and they observed this thing, when light incident on the metallic surface, at that time in all the cases the electrons are emitted. It is not happened. When the frequency of the incident light is equal to or greater than a particular frequency, then and then only the electrons are emitted. It implies that for the emission of electrons, certain minimum value of the frequency is required. If greater than that, definitely electron will be emitted. But if less than that, electron will not be emitted. And that minimum frequency required for the incident radiation to pull out the electron from the metallic surface, that is called threshold frequency of that metal. And this threshold frequency depends on the nature of the material of that metallic surface. The metallic surface which emit the electrons, that is called emitter plate. That is called emitter plate. And then with the help of these experiments, they found this thing, zinc, cadmium, magnesium, these metals respond ultraviolet light. It implies that when ultraviolet light is incidented on these metals, the electrons are emitted from it. Then some alkali metals like lithium, sodium, potassium, cesium, when are illuminated by visible light, they emit the electrons. And these electrons emitted are known as photoelectrons, and this phenomenon that is called photoelectric effect. So finally, Hallwrach and Lenard proved this thing. Yes, when the metallic surface is illuminated by the light with sufficient or suitable frequency, then the electrons are emitted from the surface of the metal. And this effect that is called photoelectric effect. Clear to all of you? Then after Hallwrach and Lenard investigated this photoelectric effect in detail, and they studied about the characteristic of this photoelectric effect. And for that, the experimental arrangement was made as shown in the figure. One evacuated glass tube with a window, which one was covered by the quartz plate, was taken, and in that particular evacuated glass tube, two metallic plates, which are known as emitter plate and collector plate. This C, that is the emitter plate, and A, that is the collector plate. Okay, and across these two plates, the battery is connected through rheostat and microammeter, and parallel to it voltmeter was connected. Here, when the light is incidented on the ammeter plate, so when light passes through this quartz window, it becomes monochromatic one. And when it incident on the emitter surface, and if this incidented light, that is with frequency equal to the threshold frequency of this metallic plate or greater than that, then here this microammeter shows the current. And this current constituted here, that is known as photoelectric current. Okay, so when here the current is constituted in the outer circuit, it implies that there is the flow of electrons in this outer circuit. So we can say this thing, when light incident on this particular surface, the electrons are emitted from it. If this light is stopped, then this current becomes zero. Okay, now they studied the characteristic of this photoelectric effect in detail with the help of this experimental arrangement. By changing the intensities of the incident radiation as well as the frequency of the incident radiation, what happens to these emitted electrons, and by applying different potential differences across these two plates, emitter and collector plate, how the change in the current takes place. So this type of detailed studies were carried out by these two scientists. Clear?